think that was all. Okay, so I will carry on with this. I used to have route flap damping in this tutorial as a highly recommended scaling technique until about 4 or 5 years ago when I stopped putting it in as a good thing and now put it in as a bad thing. So many years it was actually strongly encouraged. Pretty much from 95, 96, 97, 98, we considered route flap damping a pretty good thing to do. Really what was going on the internet, ISPs were probably announcing their customers, they would dial in, connect for a short time, announce a /24, grab email, hang up, and then 3 minutes later dial on demand would do its stuff and poll again for email. So we'd see a lot of churning of /24s on the network, usually caused by dial on demand or something similar. And it was overwhelming our poor old slow routers that we had back in the mid-90s. And so route flap damping basically came in to try and mitigate some of this issue. Well, more recent years, there's been studies, research, and whatever being done to show that route flap damping actually slows network convergence and does a lot of other evil, nasty things. So I'll come to those a little bit later on, but I'll just go through route flap damping as it is first, and then we'll look at the badness. So route flap, by definition, is basically the going up and down of a path or a change in an attribute. Yes, and a change in an attribute. That was one thing that was often overlooked by a lot of service providers. So in other words, if there's a BGP withdrawal followed by an update, that was counted as one flap. Or if a BGP attribute changed, that was counted as one flap too. Ripples through the entire internet, and it wastes CPU. Why should somebody rebooting the router in the south of Chile impact your router? It shouldn't matter. It's many AS hops away. It's in a different side of the planet. So it shouldn't have to impact your network. And that's the sort of thing that we were seeing in our backbone back in the mid-90s. Basically, somebody could do something weird on the other side of the planet, and it would have a noticeable impact on our infrastructure. So flap damping came along. Pretty much everybody wanted to do it, and lots of BMATs designs were done in various IETF meetings and NANOGs and so forth. Implementation fully described in RFC 2439. Basically, we want fast convergence for normal route changes. Trying to use history to predict the future. So if history shows stable prefix, it's likely to stay stable. If history shows prefix bounces up and down lots, it's likely to carry on doing that. We want to suppress oscillating routes, but advertise the stable ones. And implementation details, these are iOS numbers. They're probably same or different for your implementation. Penalty of 1,000 for each flap. Change in attribute gets a penalty of 500. People often overlook that, and they were going, well, my prefix is not flapping, but yeah, I'm changing the community every now and then. Well, if you change a community, that's a change in attribute, and that gets a flap. So that wasn't very pleasant. We have exponential decay of the penalty. There's a half-life rate. If you've done physics or whatever at school, you'll know what all this is about, but basically it exponentially decays like this. When the penalty goes over a suppressed limit, prefix was suppressed. When the prefix goes under, or the penalty goes under a reuse limit, then it'll be re-announced. Picture's worth 1,000 words. It would work something like that. So in other words, this is time along the bottom. This is the penalty here. Prefix flaps. It's flapped 3 times. Penalty is 2,000. It's gone above the suppressed limit. So the prefix gets suppressed. Carries on flapping until somebody figures out what's wrong. We then get the exponential decay down to this reuse limit, and then the prefix gets re-advertised. Notice 3 flaps is in a fairly short time. This is a very long time. Okay, and so typically the implementations for flap damping, you could flap 3 times then disappear for an hour, which it was deemed suitable punishment for flapping prefixes at the time. It was pretty hard to explain to customers that, well, yeah, you flapped your prefix 3 times, you're not getting internet for an hour. Okay, it's a bit like, you switch off your electricity in your house, and the electricity company doesn't give you supply for another day, just because you flick the switch. So it's, anyway, so it was quite punitive. It only applied to inbound announcements from eBGP peers, and only the path that actually flapped got punished. So if the backup path still worked, then, well, you would have best path selection that would use the backup. And you had various values that you could tweak, so you could tune the flap damping to pretty much whatever you want. Unfortunately, most ISPs just chose to use vendor defaults, and that was part of the reason for the death of flap damping. So anyway, first implementations on the internet around about 1995. Vendor defaults were too severe. I mean, first implementation was on iOS, very severe defaults, but then in Cisco's defense, what on earth should anybody use? You're asked to deploy something, what should good numbers actually be? So the RIPE routing working group tried to figure out what good numbers should be. So RIPE 178 document was the first attempt at trying to produce some sensible values. So /24s got hit really hard, 22s and 23s got hit a little bit, and everything else pretty much got left alone. Because the minimum allocation that the registries were handing out round about those days was a /19 or a /20, so we didn't want to punish those. RIPE 210, what did RIPE 210 do? I forgot. I think RIPE 229, no, RIPE 210 introduced the root name servers, because we thought, well, it's probably not a very good idea to flap dump the root name servers. And then RIPE 229 introduced configuration examples for Cisco, Juniper, Foundry, and a few others as well. I think, what else did we have? I forgot. But anyway, it was a few vendor examples as well, and there's a nice website you could go to and all the rest. Unfortunately, in spite of the working group's best efforts, many ISPs just switched on the vendor defaults because, well, they looked in the Cisco or Juniper manual and it said what to do, and that's what they did. There was no mention of the RIPE routing working group work. And then we had folks like Morley Mao and Tim Griffin and Craig Lebovitz and Abba Hujja, Randy Bush, looking at, impacts of flap damping, amongst other things. So certainly Morley Mao's work, route flap damping exacerbates internet routing convergence. She actually was showing that convergence slowed if you implemented flap damping. Tim Griffin's What's the Sound of One Route Flapping? I suppose it's meant to be copying the name of the What's the Sound of One Hand Clapping, the book, but anyway. What's the Sound of One Route Flapping? And it's a lot. It's a lot more than anybody ever expected. And, Abba Hujja's work was well known. She probably pioneered a lot of this, looking at what the routing table was actually doing back in those days. And then Randy was looking at, well, what's the chance of getting packets across the internet? I mean, you kind of think 100%, but it wasn't really that. And part of the side effects of his analysis was, what's all this flap damping going on here? Why are all these prefixes being amplified and all the rest? So it actually looked quite scary. Problem. One path flaps. Well, BGP speakers pick the next best path. We announce it to all peers. Flap count is incremented. Well, that's fine. The peers see a change in path. Well, guess what happened? Path changes, attribute changes. They all increment the flap counter as well. And after a few hops, peers see multiple changes. And they all come from different places, so your flap counters are going berserk. So I didn't really believe this, but I was doing, so when I started off doing my multi-homing things about 2001, helping some ISPs multi-home. I announced 1/24. About 10 minutes later, I went to route views, and it had flapped 15 times on route views. And I was like, okay, I've just announced this prefix. How can it flap 15 times? And then, of course, you look at all the work I cited on the previous slide, and that's exactly what they saw, for the very, very similar reasons. Different BGP implementations have different transit time for prefixes. Okay, so some of them have got this minimum route advertisement interval, so they'll actually hold on to a prefix before they pass it on. Others don't. So you've got this race to the finish line. So if your prefixes run through an all Juniper network, they'll get there at time A. If they run through an all Cisco network, they get there at time B. If they run through a 50-50 Cisco Juniper network or AS path, they'll get time C, time D, and all the rest. So you've got this avalanche of announcements all arriving at different times. And so, of course, the end sites see this as multiple flaps. Solution? Don't use route flap damping. Very easy. Just don't do it anywhere at all. Because it will unnecessarily impair access to the network and to the internet. Now, I'm going to show you some stuff in probably about 20 minutes time or so, which probably makes us think that we really need to revisit this flap damping thing, but we need to revisit in a way that actually makes it work for us. RIPE routing working group, we did RIPE 378, which basically explained the last few slides, like what the problems are, what not to do, and basically just don't do flap damping at all. So if you're still running flap damping, probably should go home and just switch it off, because it's not doing you any favors. Some people still ask me, should I still do this towards my customers? Well, if your customer's talking BGP to you and they flap the prefix, well, that's probably their issue. But if they've only got one route and it's talking BGP to you, it's unlikely they're going to flap a prefix. What they're going to do is shut the BGP session down, and that's not counted as a flap anyway. So there's probably not much benefit there. But certainly if you're providing transit to any autonomous systems, you really don't want to do route flap damping at all, as it is implemented today. Okay, using communities. So here's some examples of how ISPs will use communities. I kind of introduced communities before. This is another scaling technique. It's not a specific BGP scaling technique, but it's useful for helping ISPs scale their network operation. First thing is, there are no recommended ISP communities. There are no ISP BGP communities at all. There's RFC 1998, which is really just Tony Bates and crew at Internet MCI back in those days, just saying, hey, we use these communities to do this. And they wrote it down back in those days when you just write stuff down in RFCs and it was published. There are the 5 standard communities I mentioned earlier. There were efforts made to document them. So there was that draft that's at UCL in Belgium. So that was a BGP community survey, which only ever got to the first draft stage, but there's really been nothing else. Folks at 1SE are documenting ISP communities as they come across them, which is good. And then, of course, there was the NANOG tutorial, NANOG 40. Was it? I've forgotten who did it now. I think it was Richard Steenbergen, I think. NANOG 40 tutorial, which basically showed some of the typical communities that ISPs use. So that, again, was another nice attempt at trying to document what was going on, or what is going on. ISP policy is usually published. Sometimes it goes on their website, usually an operations page or something like that, or maybe the BGP peering page or BGP setup page. It all depends. Some of them actually put it in the Internet Routing Registry. Some ISPs actually use that, and they'll say what the community policy is in there. So I've thrown some examples up on the screen. Those of you at the back are going to have real problems seeing this one, but you can go to Sprint's website and you can find out what they actually do. Some of you at the front are going to have real problems even reading this. But, for example, this one here says 65001:XXX, and it says, do a single AS path prepend of 1239 towards ASXXX. So if you send these communities, say 65004:XXX towards Sprint, if you're a customer of theirs or peer of theirs, they will do a 4 times prepend of AS1239 when you announce that prefix towards AXXX. That can be handy. I mean, if you want to do some traffic engineering, if you want Sprint for your major traffic between them and you, but you don't want them for your major traffic to anywhere else, well, you can do a 4 times prepend towards wherever anywhere else is. Or you can do the same thing in Asia, or you can do the same thing in Europe, and so forth. Okay, and they list the peers that they have there, or at least the communities that are supported there. So you can go and configure this as you wish. More info on the website, as I said. AAPT, this is in Australia. This is, well, it used to be Connect, now bought by AAPT. They've got some communities. They're listed in the routing registry here. So, for example, 2764:2, if you send them that community on the prefixes you announce to them, they will only announce this prefix within the local POP. They will not send it anywhere else at all. If you send them 2764:4, they will local preference by 15. Remember what I said about MEDs not really being used anymore? Well, this is the alternative. You send this community here, and they will lower the MED on that particular path from the default of 100 to 85. So in other words, giving you the same effect as sending MEDs. Okay. Who else? Well, Verizon Business in Europe. I've no idea what Verizon Business in the US do, but this is AS702. Anybody who's associated with AS702 will know these, as I know them. 702.80, set local pref 80 with an AS702. So if you, as a customer of 702, send them 702:80 on your announcements, they will set local pref 80 on those prefixes. Or they will set local pref 120 on those prefixes. So again, it works like MED does, or used to do. You send them that community and will either raise the local pref or lower the local pref. So useful for traffic engineering. 702:1 does a single prepend, 702.2 does double prepend, 702.3 does triple prepend. These seem to be very common. Not only Verizon does these, quite a few other ISPs I know do these ones. So I think they're pretty much, even though they're not standard, they're pretty much industry de facto standard values that are being used. And the various other ones. I'm not going to go through them all, but you can see the examples here. Do different prepends and announcements in different regions and so forth. BT Ignite, this is well, it's more worldwide network, but definitely European network. Tiscali, many years ago, had a hugely complex set of communities, which I thought were great. They don't seem to have them anymore, but BT Ignite borrowed them, and so they've implemented them like this. And so you look at them, again, if you look in the AS object and the RIPE routing registry, you'll see things like 5400:1000. If you attach that to a prefix, they will not announce it to any of their peers or transits. Or if you send them 5400:2000, they'll do a single prepend of 5400 to all their peers or transits. Okay. And then they've got the transit providers here. So, I mean, if you don't want to announce the prefix towards Sprint, you send in that community. If you don't want to announce it towards AT&T, you send that community, and so forth. Have a look at the AS object. It's a huge list, pretty sophisticated list, and I'm sure some of you could borrow this for your own network as well. So you as a customer send these communities to BT Ignite. They will do what they say up there. Level 3, they've got a very complex one. Again, if you look in the RIPE routing registry, you'll see this one for AS3356. Similar stuff, you know, they do a single prepend to peers, they do single prepend to particular AS that's supported. They will do set local pref 70, 80, 90, pretty similar to the MED ideas. There's the black hole one, 3356:9999. I was explaining to somebody during the break. This is wonderful. I wish every ISP would do this. If you're being attacked as a customer of level 3, you basically send your prefix that's being attacked, /32, with this community tagged onto it, and level 3 will basically sync the traffic for that address space into their distributed sinkhole network. It's pretty neat. It's a way of stopping, well, not stopping the DOS attack, but keeping the DOS attack out of your downlink to your network. If more ISPs around the world did this, it would be much easier to work to try and defeat some of these DOS attacks on the go. But that's what level 3 actually supports, which is really nice. Okay, so those are some examples. You can find a whole heap more sitting around on the network. So check with your upstream provider, see if they support communities, at least some like this, because it can be really useful for you doing your traffic engineering. I generally put this in the multi-homing tutorial, but I've added it into this one because people always ask me at the break, okay, what about communities for external BGP? Don't we do those as well? So I've thrown them in for this presentation as well, just so you see how they work. So let's get on to the second piece, deploying BGP. We've learned all about it. What do we do? Well, look at the role of BGP versus the IGPs first. So we've got the IGPs, interior routing protocols, ISIS and OSPF are pretty much the favorites these days. The service provider space, you don't see many ISPs using much else. If you look in the enterprise space, things are a little bit different. EIGRP tends to be the overwhelming favorite with some OSPF, but very much for the service provider space, ISIS and OSPF seem to be dead heat in popularity. They're used for carrying infrastructure addresses, your router loopbacks, your point-to-point links within your infrastructure, and that is all, nothing else, full stop. Okay? Design goal for most ISPs is to minimize the number of prefixes carried in the IGP. So you don't put internet prefixes there, you do not redistribute from BGP into ISIS. Even though the command exists, does not mean it's a good thing to do. Do not go whining to your vendor that you cannot do it. Okay, and it doesn't work properly or your router crashes. An IGP is not intended to carry 270,000 prefixes. Don't put your customers there either. A lot of people still seem to think, yeah, we'll drop our customers into OSPF, and then we'll redistribute OSPF into BGP at the border, and hey, everything will work just nicely. Well, I'm sure something will work if you've got 10 customers, but when you've got 10,000, it may not work so well. Convergence of your network will really be severely impacted. So most design goals are to minimize the number of prefixes in IGP. Put them all into BGP. We've seen this before in the first half. You've got iBGP and eBGP. Treat them as different routing protocols with different aims in life, and then you won't go far wrong. I'm going to come back to that particular theme a little bit later on when I start one of my favorite rants. Okay, iBGP, that's where you put your customer prefixes. iBGP, put your internet prefixes, the prefixes you learn from your peers and your transits in there. eBGP is what you exchange, or what you use to exchange prefixes with other autonomous systems. Okay, what goes in eBGP is not necessarily the same as what goes in iBGP. That's the model. We've seen that before. Do not distribute BGP into OSPF or ISIS. Yes, the command exists. Doesn't mean it works very well. Don't distribute IGP into BGP. Yes, the command exists, but it probably won't work so well either. You probably cause BGP to go into frenzy because OSPF and ISIS change very rapidly and a lot. BGP does not like change. So if you want BGP process to go, well, gobble a lot of your CPU, carry on redistributing. Don't use an IGP to carry customer prefixes. If you don't do any of these things, your network will not scale. Okay, I'm not just saying because I'm standing up here saying that. This is like the experience over the last 15 years of seeing ISPs build their networks. This is the really only way to try and get scalable networks to function. Putting prefixes into iBGP. Well, iBGP carries customer prefixes. Don't use OSPF ISIS. Generally, you point a static towards the customer interface. Network statement, put the network into the BGP process. Network statement, redistribute whatever you want to do, however you do it. You want to try and also avoid iBGP flaps. One of the still frequently asked questions is, ooh, my iBGP is churning a lot. Can we get flap damping for iBGP, please? No, you cannot. Okay, and the reason I say no, you cannot is because, well, if your network design is broken, then, well, fixing it with yet another feature in BGP is really not the right way. Interface flap generally means if you're redistributing, say from a static route into BGP, if the interface goes down, well, the static towards the customer disappears, so the prefix gets withdrawn from iBGP. If you're a small network, this probably doesn't matter so much. For a big network, you have loads of customers going up and down all the time, you probably don't want your interfaces to flap. So certainly there's some ways, again, depends on the implementation, to ensure that the static route is hardwired so it's always in the routing table so that you'll never get a flap in the iBGP. Aggregation, quality or quantity. Aggregation means announcing the address block you receive from the registry to the other ASs connect to your network. I always kind of thought, maybe I've been in this business far too long, but I always thought this was kind of obvious, but it doesn't seem to be obvious anymore these days. Subprefixes of the aggregate can be announced internally in the ISP network. Obviously, you're going to give subprefixes to your customers, right? Maybe 24s, 23s, 27s, 29s. Those all go into your iBGP. You may announce subprefixes to other ASs to assist with multi-homing as well. Okay? Now, the subprefixes you announce to aid with multi-homing, stealing from the multi-homing tutorial that I sometimes do, it's not a case of you take your address block and chop it up into the smallest pieces possible and just spray it out there and hope something works. Okay? You actually need to do some proper engineering to try and figure out where things should go, how they should go. Careful work. But unfortunately, too many people are still thinking about Class Cs or something or other, and they're chopping the address space they receive down into /24s. As you'll see in a few slides, but well, it's getting close, for 60% of the routing table today is made up of /24s. Quite incredible. Address blocks should be announced to the internet as an aggregate. Subprefixes should not be announced at all unless we're trying to do traffic engineering. More later, well, later is when I next talk about that. Aggregate should be generated internally. Some people generate aggregate in the border router, which is generally fine if the border router is within your network physically. If the border router is somewhere remote, connected by thin string to your backbone, well, if that thin string breaks, you still generate your aggregate, and your backup no longer works. If you get a backup path some other way, well, your border router is still announcing the aggregate, so it gets round the internet, close to where your, the return traffic comes back, sees the best path is via your border router. Traffic comes into the border router. It has no best path anymore, so it drops everything on the floor. Been there, done that many times. So try and generate aggregates within the core of the network rather than out at the edge. Then you save cutting yourself off. Announcing an aggregate, well, ISPs who don't want aggregate are held in general poor regard by the community, at least by some parts of the community. Other parts of the community don't seem to care very much at all. They're quite happy to go spending their hard-earned dollars at the vendors, buying really, really expensive memory or really, really expensive router upgrades. The registries publish the minimum allocation size. Again, it's anything from a /20 to a 22, depending on the registry. I mean, APNIC just, well, a month ago went down to /22 minimum allocation now. I think ARIN is still a /20. So it'll be different from different registry regions, and it'll be different for different address blocks as well. APNIC's minimum, for example, used to be a /19 a few years ago. So you'll still see some address blocks /19, whereas others are now appearing as a /22. So there should really be not much reason for seeing many prefixes longer than a /22, you would have thought, but the more than 141,000 /24s. Aggregation example. This is some of the stuff that I see going on to try and explain to people why aggregation is actually reasonably important. So a customer's got a /23, AS100's got a /19 address block, and what does the AS100 do? They go, ooh, I'm running BGP, wow, I'm very clever. And what they do is, every time they hand address space to the customer, they announce it by the eBGP out to the world. And if you don't think many people do that today, oh yes, they do. Go and have a look at the routing table. Pick any random AS. You will see loads of this. Loads and loads and loads. They basically leak the iBGP out to the internet. And they don't think about it. See, what's the problem? The internet carries everything. You know, it's all good and everything's working just fine. Well, here is their just fine. Custom link goes down, 23 network becomes unreachable. It's withdrawn from the iBGP. ISP doesn't send any aggregates out at all because, ooh, aggregate, ooh, that's going to take up memory in my router, so they don't. 23 network withdrawals announced to peers. All 29,400 autonomous systems in the internet will see this withdraw. Added load on all the internet backbone routers. Customer link returns. He comes back next day, switches the router back on. And of course, when you switch a router back on, you'd want your network to work. I mean, you'd walk into a room, you switch on the lights, and they work. You come back from a day's work at the office, come into your house, switch on the lights, you expect them to work, don't you? But it doesn't happen here. The 23 is re-advertised to peers, goes into iBGP, announced to eBGP peers, starts rippling through the internet, load on the backbone routers. Some ISPs are still doing flap damping. All ISPs, some using different vendors. You've got all this different race to the finish line I was talking about before the break, flap damping coming in. Prefix gets flagged, suppressed for 30 minutes, 60 minutes, longer, depending if people use defaults or not. Internet may take 10 or 20 minutes or longer to be visible, and may be bumpy for the next hour or so. Where's the quality of service? Okay, customer's trying to browse the net, download his email, finds that nothing works, phones his ISP. ISP says, I know what you're talking about, it's all working fine here. Go reboot your PC. You see this happen so often. And actually, it's the ISP basically not being very good. Or being incompetent, basically, because that's what it boils down to. Every time the customer prefix flaps, the whole world gets to see this particular impact. And it does happen. I've got some examples coming up. Extraordinary examples. Here's a good example. I mean, if people just did a bit of aggregation, so the ISP AS100 generates its aggregate, sends its aggregate out, his customer gets a /23, link goes down, it's withdrawn from the iBGP, the aggregate's still announced, nothing happens. Customer come back next day, switches his router on, 23 is re-injected into the iBGP, suddenly can see low internet. This is how it should work. So why do a lot of people think this example is no different from the previous example? I mean, I do tour a lot of the world and I do this slide and people come up to me, well, it's a very nice example, but I don't understand what you mean by the differences here. I don't understand why it's different. Many ISPs need to become customers of themselves, I think, to actually understand what some of these things are actually impacting. Because they don't, if a customer is out for an hour, they don't really think about it. They sit in their NOC, they get the connectivity, therefore it works okay for their end customer as well. Good example is pretty much what everybody should be doing. Okay, it adds to internet stability, reduces the size of the routing table, reduces routing churn, and it generally improves the QoS for everybody. People get so obsessed about doing rate limiting and packet shaping and all the rest, they can't even get the basic QoS stuff like this, actually ensuring that people can use the network when they want to, actually working. And why do we have this bad example? I mean, is it laziness, lack of knowledge? In some cases, lack of knowledge. Generally, it's just laziness. People don't understand the difference between iBGP and eBGP and so forth. If we look at the table today, well, this wasn't today. This was about 4 days ago when I put the slides together. 270,153 prefixes. I think it's about 270,900 in my view now, so it's gone up about 600 in the last 3 days. I do aggregation. This is analysis stuff that I do. I take the routing table and I aggregate it. So as what it could be if everybody else did aggregation, and it pulls it down to 130,000 prefixes. Right? So I could actually have a BGP feed, 130,000 prefixes, and lose no information whatsoever. So there's 140,000 prefixes of junk. That's quite a lot. How much memory does that take up? What does it cost to buy it from your favorite vendors? Yeah.
You seem to actually, the slides were labeled aggregation, but you seem to be arguing for pinups and paper in place of aggregation.
Well, I'm arguing for aggregation. I mean, there's a lot of people who subdivide prefixes. But yeah, I mean, pinups are important.
Yeah, because if you don't do the pinup, then anytime one part of it drops out, it's going to be aggregated.
Well, for sure. But there are a lot of people who are not actually doing the pinups either. They're simply leaking iBGP out to the world. I mean, you can have a look at the BGP table just to see it. So yeah, I mean, I suppose I'm arguing for both things. Yes, I'm pointing out what happens if you don't have the pull-up routes, but yeah. Slash 24s announced, as I was saying, 141,000 of them. People are quite happy to blame, oh, it's all caused by network 192/8, which was the original class C from years and years ago. 192/8 is the best behaved of all the /8s around. It's been about 5,500 prefixes for probably the last 10 years. Okay? It's the best behaved. The rest of them are very, very messy. So 29,400 autonomous systems, as I said. So after aggregation, I mean, this is aggressive aggregation. I mean, I'm sure the routing table won't be quite as aggregated as that, but if I aggregate by origin AS, I can pull it down to 130,000 prefixes. So I don't know, I've called this a new swamp space. In the old days, we had swamp space, which was 192/8. 192/8 was a mess. Certainly not long, 94, 95, it really was a big mess. Because what happened pre-CIDR was ISPs were getting blocks out of 192, so they were getting blocks of Class Cs. And the big effort to reduce the swamp in 192/8 was to get people to aggregate these blocks. This has all happened now. If you look through 192, it's actually pretty tidy. It's looking in some of the other blocks, things are not so tidy. So this is 1999 when I started poking around in all this. So these are all the /8s that are now have been assigned to the registries, the 5 registries today. So if you look through them, there's actually not a lot happening. I mean, 192/8, even in 99 was 6,300. So it's dropped about 500 prefixes from 9 years ago. If we look at 193/8, 2,390 prefixes. I mean, that was the first one that the RIPE NCC got. It was the first address block used in Europe. And it was sitting around 2,400 prefixes for many, many, many years. I mean, it's been fully allocated for goodness knows how long. So watch that one as it moves over to the next slide. 202/8 was APNIC's first address block. Well, it's a bit funny. It was actually AUNIC. So they got a fair chunk of that address space. And Telstra for a long time announced, I think it was 202/12 or 11 or something like that. So certainly in 99, it was nice and tidy, 2,276 prefixes. 203 also was APNIC, 3,622 prefixes. Fully allocated address blocks in 1999. So what has changed between 99 and now? So if we look at, 192/8, total prefixes 6,929. That's not changed very much. 193/8, it's gone up to 6,220. What exactly has changed? I mean, that's a fully allocated block from the RIPE NCC. Why does it need to be disintegrated so much? But these two are amazing. 202/8 is now almost 11,000 prefixes, and 203/8 was 11,000 prefixes exactly. Okay? And you look back in 99, fully allocated, that size. Today, they've gone up to that. So that's quite amazing. If you look at most of the rest of them, they're around about 5,000 or so. So you look through all here, ones that are fully allocated tend to be hitting around about 5,000 or 6,000. Okay, so this is really what's going on. So the registry blocks are contributing about 89% of the internet routing table. And that's actually been consistent. If we go back to February, again, the registry blocks are contributing 88% of the routing table. So this also means that the other address space, the legacy address space, is also being deaggregated as well. So yeah, showing creeping deaggregation. I don't know, just kind of waving my hands, but if assuming 5,000 prefixes once fully allocated, we could end up with maybe 440,000 prefixes in the BGP table. And if the remaining 39 unallocated /8s, we could probably end up, I don't know, this is just complete waving my hands in the air, maybe 850,000 prefixes in the BGP table. How much memory do you need to handle that? So people probably should start thinking about that. When will we be fully allocated? Probably 3 years from now, maybe sooner. So I don't think these numbers are really that far away. And certainly if you look at the graph of the growth of the table, which is somewhere coming, you'll see that the growth is accelerating. Yeah, so rest of the address space is showing this deaggregation also. And a lot of the justifications are for traffic engineering. Now, a lot of traffic engineering is really well thought out, where people take the address space and maybe divide into 2, 3, 4, 5 pieces. There's a lot of other traffic engineering that's simply taking the address space, chopping into 24s or 23s or something like that. And it doesn't really seem to have very good justification for it. I looked at this when Jeff Houston does similar analysis work based around on his website. I mean, I did this one, well, as you see, October 2 years ago. And I found that it's probably about 35% saving is possible simply by throwing away all the traffic engineering information. So I suppose if everybody's using the no-peer community, we probably could reduce the routing table fairly noticeably. Okay. Anyway. So excuses tend to be like, well, traffic engineering probably causes about 10%, so real traffic engineering that we can't avoid. And then there's deliberate deaggregation where people are just announcing lots of small prefixes on the same path with or without covering aggregates and for no reason apart from they think it's good fun and they can do it and other people accept it. So efforts to improve, well, there have been loads of efforts to improve. It's not as though we're just all standing here going, oh, it's terrible, it's terrible. The CIDR report was the first one. CIDR report actually started off trying to encourage people to move to classless routing from the old classful routing. So it was trying to encourage people who got legacy 192 space to actually join the groups of 24s they had into bigger announcements. So Tony Bates started that off. I think he was still at RIPE NCC when he started it, but he carried on when he was at Internet MCI and when he was at Cisco, and then he handed over to me, and then I handed it over to Jeff. So it's all got a nice website, a lot of work that Jeff put into it at www.ciderreport.org. And it generally lists a whole heap of things, but includes the list of 30 of service providers or autonomous systems who could do better at aggregating. We're also the RIPE Routing Working Group. This is Mike Hughes and my fault, along with Rob Evans from Ucarna, was the RIPE 399 document, which basically looked at some of the causes of aggregation and tried to encourage ISPs to actually consider announcing aggregate and be more considerate when doing traffic engineering. So we documented a lot of the current practices and so forth, so that's in the RIPE 399 document. It's been translated into Spanish. Was it last year I think that was done? And about 3 days ago it's been translated into Japanese. So the internationalization folks at NANOG actually did that work. So for our Japanese speakers here, you can go and read all about it in Japanese as well. And if you feel brave, you can compare it with English version and see how well it's mapped across. If anybody else wants to translate it into any other languages, you're very welcome to do so. Anyway, so the CIDR report, the website allows searches and computations of aggregation to be made on a per AS basis. So there's actually a tool in there. You can pop your AS number in and find out things about it. So let's look through the website quickly. So going to the home page, ciderreport.org. So you can see, well, Jeff's view is, where is it, 282,000 prefixes he sees, which is a wee bit more than I see. I'm seeing, my view is that Dixie in Japan, Jeff's one is what he gets from, where does he get it from? I think he might get it from Telstra still, or Reach or somebody. Similar kind of AS numbers and so forth. So the aggregation summary. So here are like the top announcements into the internet. So let's see, I think this is ordered by net gain. So the service provider that could contribute most to the size of the routing table, or at least help reduce it most, is the China Education and Research Network, who are currently announcing 5,033 prefixes, but if they aggregated, could reduce it to 880. So 82% reduction possible. Number 2 is Bell South. Number 3 is Quest. Number 3 is Paytech. Number 5 is Cox. Tata Communications. They're, well, number 2 in Asia for deaggregation. So that's VSNL, or, yeah, which is basically India, national ISP. With that AS. Hathway is cable provider in India. Uninet, where are they? Mexico, I think. Cox Communication, and so on through the list. So they're the savings that could be made with bigger efforts at folks trying to do some aggregation. I should mention that ChinaNet used to be fairly high up on this list. Where are they now? It's not that one. They used to be on this list. They used to be pretty close to the top on the list. And I think I'd given this presentation in front of other folks once too often, but they actually sat down and worked really hard to do a fairly substantial amount of aggregation. So it can be done. I mean, I know it was like a 6-month project that they were involved in to try and improve things. They basically got, I think there was a /12 worth of address space was chopped down into about 19s, 20s, 21s. And it was done per province, per city in each province. And we're looking at like a large number of cities in each province. And none of it was aggregated. So they aggregated on a provincial level and on a national level, and they've pretty much disappeared from this list. So it is possible to tidy up. So we've top 20 routes added, top 20 withdrawn, more specifics. So like CRNet announcing 4,954 more specifics. So they've got covering aggregate. They're just announcing all the specifics as well. And so you can see that in the list also. So I've picked at random, well, here's Tata Communications. Because this appears number 1 in Asia, and I spend a lot of time in Asia, obviously, because I live there, this one features quite a lot in my BGP presentations. But you look at the sort of things that are being announced, I mean, 24s, 21s, 24, 24, 21, and they're contiguous. Okay? They're basically, and I mean, I've seen an iBGP feed from them as well. Guess what? It looks exactly the same. Right? I mean, don't want to cast aspersions, but I basically believe there are no filters between AS4755 and the outside world at all. Whatever they have in iBGP just goes straight out there. And so the CIDR report, I mean, you can put the AS in, and it will tell you, look, you're announcing 51.160/14. You can withdraw all these prefixes. Everything in red could be withdrawn quite easily. No loss of routing information whatsoever. COVAD, well, I always put this one in. But again, it shows a lot of the possibilities. Announcing loads and loads of 23s and 24s could all be aggregated into the /16 that it comes out of quite easily. So you put your own AS number in there, and you can see what it's doing. Anyway, so size of routing table. So people have said, oh, well, memory is not a problem. The vendors have come along saying, yeah, we'll give you 4 gig of RAM in your routers. Well, that's fine. You know, you can pay the expensive prices for it and all the rest. Yes, 1 million prefixes have been tested in the lab, 2 million prefixes, it's all going to be great. What about convergence? How long does the CPU actually take to handle 1 million prefixes in the BGP table? Especially if they all change. You want to change the next hops. Sure, we can throw faster processors and all the rest in, but it all takes a finite time. why is all this necessary? I mean, you can speed things up simply by not having to handle a lot of this junk. So Jeff actually started about 2 years ago this BGP instability report. So he looks at the instabilities in the routing system. And this makes interesting reading. I don't know how good your mental arithmetic is, but have a look at this one. AS9583 is generating 276,000 updates per month. You divide that out into how many updates per minute it is. I think when I did the numbers, it's like 3 a minute. So they're sending 3 updates per minute from that AS. So that's from Satyam Infoway, SIFI in India. I mean, this was the AS1803 ICM Sprint is basically miles away in comparison. Or CRNet in China, they pop up again, 100,000 updates per month. So these are the sort of instabilities. There's some really amazingly bad ones. This one hasn't been quite so bad, but some days you look at this, it's just extraordinary amount of instabilities there. But we're looking at like updates, many updates per hour coming from particular autonomous systems. I mean, if you look at prefixes themselves, the most bouncy prefix in the world at the moment is 192.12.120/24, which is 78,000 updates per month. So that would be, what, 1 every 2 minutes? So does that sound like dial on demand, all day dial on demand? But I don't know how things can update every 2 minutes. It just doesn't seem feasible. But we should damp that completely, and that's the point. A lot of the folks who have been looking at flap damping are saying flap damping should be done totally, not per path. And you can't configure total flap damping on any of your routers at the moment. I mean, I think it would be really nice. I mean, I would like to try it. If I can have a knob to actually do flap damping, so if any prefix flaps, it's all gone, completely, utterly, and absolutely. That's what I would like to see. But I only work for a vendor. It needs customers to actually get features done. I can't get anything done at all. So if you think that flap damping should be done absolutely, please go and beg to your favorite vendor to get them to do it. Because I think that would actually make a big difference and stop a lot of this stuff. Because when you look at it, I mean, SIFI is causing a lot of it. And it's not that I haven't spoken to them about it either. Okay. Anyway, so that's tracking the updates, the instabilities in the routing system. Note this is the view from, I think it's pretty much from the Telstra's network in Australia. It will be different in different parts of the world. So I need to check with Jeff. He's actually not here in the second half, but I need to check with Jeff what views he actually gets to see these instabilities. But if any of you want to track it in your part of the world, I'm sure I'll be delighted. Anyway, so aggregation potentials. This, again, is just taken from Jeff's website because it shows it better. So there's the routing table today, onwards and upwards. This growth rate here, when I sort of pulled it out and put a curve against it, it's actually faster than it's ever been. It's faster than this piece here. That was just before the dot-com bust, 2000, 2001. Today, it's faster than it was. I'm not going to draw any parallels to the financial collapse that's happening around our ears, but maybe we can predict financial collapses just by the rate of growth of the routing table. Anyway, sorry. What I was going to say is if you actually aggregate by AS path, it can pull the BGP table down there. Aggregate by origin AS, it pulls it down there, which is more the numbers that I'm getting. I aggregate by origin AS. Jeff aggregates by AS path, which is up there. So having something like this in the router could actually be useful. I know some ISPs actually do filter what they get. But again, there's no real knob that you can switch on in your router that I'm aware of that if you see an aggregate, it will ignore all sub-prefixes. Because I think more people are going to start asking for that rather than pay thousands and thousands of dollars just to get extra gigs of RAM. Anyway, so I would say 35% saving is quite feasible in the routing table today. Okay, receiving prefixes. This is getting back to best practices. I'll stop my aggregation right now. Receiving best practices, the 3 scenarios for receiving prefixes from other ASs. If there's a customer talking BGP, your peer, or an upstream. And you kind of have to treat them all differently. You can't just treat them all the same. Right? They've got different filtering requirements, and you need to handle them separately. Firstly, customers. You should only accept prefixes from your customers that you know they're actually entitled to use. So if your customer wanders up to you and says, hey, I've got such and such an address space, check that it's actually theirs, not just something they've made out of thin air or something like that. Check that it actually is their address space to announce. I mean, obviously, if you've assigned them an address block out of your own space, it's fine. But if they're turning up with their own address space, check that it really is their address space. That's all you can do. There's no other authoritative way. You have to check up the registry database, and it is actually theirs. If they're the registered, well, user, then you're probably fine to announce it.
Question.
Yeah.
Does that make it harder for your customers to announce their address space on your network than it does for them to announce it to peers?
Does that make it harder for them to announce address space in your network rather than for peers? No, I don't see why it should, really.
Should peers check the
Yes.
address space?
Yes. Yeah, I mean, I'm going to do that next. Yeah, peers should be checking address space as well. Yes. I mean, I would even say upstream should be checking address space too. Well, there's some classic cases where upstream's quite happy to accept whatever the customer send them. We've heard of 1 or 2 instances in the past. So, but yeah, it's generally filtering, check what the customer's entitled to send. If they're not entitled to send it, don't accept it. So there are the 5 registry databases, and that's pretty much all that you can check. Very simple tool, whois. So some registries have a web interface to the whois tool, but you don't have to do that. I mean, most Unix systems these days have a whois command. You just do whois and look up the address space. And if the customer doesn't match the one who's coming along, then you need to start asking questions. So I've just thrown some examples in here. I mean, if it's a portable address space, it's like somebody turns up and wants you to route 202.12.29.0. Well, you look it up and say, oh, that's APNIC's address space. Well, if they're not APNIC, then you probably don't want to start announcing this address block, for example. Here's another one. Somebody turns up with 193.128.2. Well, if they're not Wood Mackenzie, if that still belongs to Wood Mackenzie, then, well, you shouldn't be announcing the address block. Right, so from peers, well, it's somebody with whom you agree to exchange prefixes you originate into the internet. So it's generally, private peering, so you're giving reachability into your network to them, and they're giving reachability into their network to you. So that's pretty much all that you should be doing with a peer. So the prefixes that you accept from them are what they're entitled to announce. So again, you would agree as part of the peering arrangement what you're going to exchange with each other. Now, I mean, you could agree various ways to do it, maybe exchange emails with each other, or maybe you decide to use a routing registry, or something like that. But at least you come to some agreement what you can and cannot accept. Again, some of the peerings I've seen, especially at internet exchange points, it's like open season. Yeah, I'll accept any old rubbish you send me, and I'll send you any old rubbish that I have. That's only going to end up with serious accidents. If somebody sends you a default route across your private peering, well, you'll end up using their links for all your outbound traffic rather than your own links. And your own links are probably a lot better than theirs, for example. So you agree what each other are going to send, or use the Internet Routing Registry. Quite a few ISPs use the Internet Routing Registry. If you want to automatically configure your routers and so forth, or semi-automatically, you can use the IRR toolset, which ISC look after, or you can write your own scripting to do that. I mean, again, ISPs either do their own scripting or they use the IRR toolset. So that's all possible. What about upstreams? Well, the upstream are your transit providers, the ISP who you're paying to give transit to the whole internet. So do you want to receive full prefixes from them, all 270,000 or so? Well, I mean, you can do if you want to. I always ask the question, do you need to? What's wrong with the default route? Default route says, I know how to get to the internet. I mean, if your upstream provider's only got a single connection to the internet, then you probably don't want just a default route from them, because they don't have any redundancy. But if they're well connected and so forth, getting a default route from them is probably a good thing to do. It certainly saves you 270,000 prefixes, and boy, does it make your BGP convergence speed up. If you've got any link failures, you will fail over to backup links in a matter of seconds rather than a matter of minutes. So having a sparse BGP table is generally a pretty nice idea. If you're a transit provider, it's probably slightly different. I mean, if you're a transit provider, you probably want to have the full BGP table, because then your customers probably want to have full table or substantial table or something like that, and it gets too hard for them to try and do any multi-homing. But if we look at the internet today, although what, 3,500 autonomous systems provide transit, 26,000 are end of the internet. They're not providing transit anywhere else. So if you're not providing transit to other autonomous systems, ask yourself, why do you need a full BGP table? So if you want to receive prefixes, again, don't just accept any old rubbish. Again, many historical accidents have happened because people have accepted any old rubbish. For starters, you don't want to receive the private address space. There's a lot of prefixes in RFC 3330 that are special use. Some should be routed, others should not. So check those up just to make sure that you're getting the right stuff. Don't accept your own prefixes. Why would you hear your own prefixes from anywhere else? That's pretty unusual. Don't accept the default route unless you need it, because from time to time the default route does get announced by accident. So you probably don't want to hear a default route from some places you weren't going to expect it. Some people are now allowed prefixes longer than /24. It seems to be, again, industry standard of not accepting anything longer than 24. So 25, 26s, 27s, 28s, you don't expect to see these. There are not many of them anyway. It's not going to cause a massive problem, but generally you don't see them. If all this is too much for you, well, Team Cymru have a nice service. They've got this Bogon route server, which basically will send you a BGP feed of prefixes that you probably don't want to see on the internet. Okay, so you can sign up to that service if you want to do it, or anybody else who offers a service like that. And I know quite a few ISPs who are using it who are perfectly happy. But for goodness sake, if you're going to do this sort of Bogon-based filtering, say for like the registry unassigned prefixes and so on, keep it up to date. I'm not going to tell my Mongolia story in this thing. I don't have enough time, but there's many classic examples of people putting static filtering in and not updating it. So it's easiest to use this route server, and that way you ensure that the prefixes that you're receiving will always be current. So anyway, so generally paying attention to prefixes you receive from customers, your peers, transit providers, it all helps with integrity of the local network and with integrity of the internet. So I say many of the accidents on the net have happened simply because people have not been filtering appropriately or properly. Nobody owns the internet. Well, we own the internet. So if we want the internet to work as we expect it, then we really need to behave properly on it and look after it. Right, so the final piece, configuration tips. I'm just going to go through some configuration tips, templates, and so forth. A lot of these are good practices. Some are arguable good practices. But I've put on here a lot of the ones that I found people insist are really good ideas. The first one really, well, use loopback for iBGP peerings, because that way we keep our iBGP independent of our infrastructure. Some people still run iBGP between real interfaces. The downside is if a real interface goes down, your iBGP will go down. Put the loopback 32 into the IGP. Think about the demarcation zone networks. So do you want to use unnumbered interfaces? Some ISPs use unnumbered interfaces for point-to-point links to customers. A lot of ISPs, more and more these days, are using next hop self. So they set the external next hop or replace the external next hop with that of the local router. Some people carry the demarcation zone /30s in BGP because they monitor customer links. So you don't put them in the IGP, you put them in BGP. We tag them with a special community, and only the router that connects to your NOC will let that community through so that your NOC can actually see the point-to-point links. That kind of thing, perhaps. But basically, you want to keep all the demarcation point-to-point links out of your IGP, and that keeps it nice and small. So that's the next hop self. So the BGP speaker will announce external network using the router local address. And that is very useful to help reduce the IGP. Some people limit the AS path length. I mean, the internet on average is 5 autonomous systems deep. I mean, even crossing the network, I think the longest AS path with unique ASs without any prepends is something like 12 or 13. So the internet's not really that broad. It's very, very dense. So some ISPs go, well, if I'm only really going to see about 13 or 14 max, why should I see an AS path with 60 ASs long? So they limit the number of the maximum AS path length to around about 20 autonomous systems. Okay. Again, I track these numbers. The internet is generally the longest AS path, sometimes, usually about 14 or 15. And then every month or two, it pops up to about 50 or so, because somebody does a 40 times prepend because they don't know how local prefs work or something. So some ISPs will do this. I mean, there was something, was it 2-3 years ago? There was somebody tried to do a 255 or 256 AS path, and it corrupted, because in the software it didn't actually check, because nobody ever thought that ASs will ever be more than 255, so it didn't actually check in the software whether it would be longer, so it overwrote some other memory and started causing routers to crash. So you see some ridiculous examples. This is an old one from the days of the 6-bone, the IPv6 experimental network, long gone. But you saw something absurd like this. This was actually caused by a bug, a withdraw bug, but you still see these ridiculously long AS paths. And here somebody's done a massive AS path prepend, AS16327. This is the best path. It's the only path in the routing table, but they've done a big prepend for some reason. Okay, no, doing massive prepends will not override local prefs. So anyway, but there are more classic examples. 20 is mild compared to some that I've actually seen. So some people actually now limit AS path, the maximum length of the AS path. So the prefix has more, let's say 20 ASs in the path, they ignore the prefix altogether. There's a BGP TTL hack. Again, it's limited deployment I've found. I mean, RFC 5082 describes this. And it's a bit of a neat trick. It's designed to stop DOS attacks in BGP sessions. So the way this works is, and you're basically your router's sitting here. Well, normally your TTL, it'll be 1 here, TTL 0 there, which is fine for somebody sitting out in the network because they can send crafted BGP packets with the right TTL to try and disrupt the BGP session here. Well, if router 2 sets the TTL to 255, then router 1 expects the TTL coming in to be 254. So router 1 is told, expect the TTL from router 2 to be 254. Or 255, I should say. Okay, expect it to be 255. Then, well, the BGP session will work on that. The beauty of this is an attacker sitting out here has to send a packet. The TTL will be reduced. It arrives at router 1 with a time to live of 253. So router 1 goes, well, that's not for me. Wrong time to live. Goodbye. So it's a pretty neat trick, which some ISPs are using to try and avoid having these general attacks on BGP peerings. So there was a NANOG presentation back in 2003 explaining how this all works. As I said, it's in the RFC. Some ISPs use it as it gives them, as I put in brackets or quotes, the security for the BGP sessions. So some ISPs consider it useful. Note that both neighbors have to agree to use the feature. You can't just decide to set it up yourself because your neighbor will still send packets with TTL1. So it won't be too useful if you try and configure it. Templates. I always think templates are great things for doing configurations. There's nothing worse than trying to do custom configurations for every single router in your network. Most ISPs have what? Core, distribution, aggregation, border, service, system, whatever, routers. So if you have standardized configurations for each one, then it makes managing the network much easier. You just put the standardized configuration. If you need to make a change, you update your template, and then you upload it to all the routers. And then you know all the routers will get the update. It's much easier than running around each one and making custom changes. Also, vendor defaults tend not to be optimal or even very useful for ISPs. Just because a vendor has decided that one thing should be a default does not mean it should be the default. You need to decide what the default is for your network. I mean, yes, there's some obvious defaults that the whole industry thinks should be, but the problem with a lot of vendors is they service more than one market. So trying to find a nice default that fits into all markets is probably a bit of a challenge. So what you find is the ISPs tend to just create their own templates. There's some industry well-known defaults. Folks like the Team Cymru keep these. If you look in their reading room, they've got various router and BGP and all the rest templates, which are considered industry best practice, good practice, people favorites, and so forth that you might like to consider adopting for your own network. So I've put some IBGP ones here. So IBGP between loopback interfaces, pretty much standard. Next hop self, pretty much standard. Sending communities in IBGP, otherwise accidents will happen. If your neighbor sends you a prefix with no export and you don't send communities within your IBGP, your neighbor's wasting their time and you end up leaking the prefix that he wanted to be suppressed. Hardwire BGP to version 4. Yes, there's still some comedians out there who try and set up BGP version 3. Or there's some people who like playing around with BGP version numbers. There's no BGP version 5 yet. So some ISPs make absolutely sure BGP is hardwired to version 3. Some people use passwords. A lot of people use passwords in IBGP sessions. Within the network, that can be pretty useful. I see it more used outside the network for eBGP sessions. Again, with a view of all the ISPs, I see some of them mandate passwords, others will absolutely not use passwords. So your mileage may vary in what you want to actually try and do. Honestly, I don't think there are many people who tag BGP sessions, but I think we're all working in a paranoid phase right at the moment. It's a pretty powerful prevention tool, especially when it's combined with filters and the actual TTL hack I mentioned earlier. BGP damping, do not use it unless you understand the impact. Some people still use it, and well, if they understand the impact, that's fine. And definitely don't use any vendor defaults, flap damping or otherwise, unless you really understand why. Remove private ASs from announcements. Private ASs should not appear on the public internet. So most vendors, again, have nice commands that will strip out private ASs from AS paths. Use extensive filters with backups. So some people use, say, prefix filters to filter prefixes and then back them up with AS path filters. If you've got a private peer with a neighboring AS, then put in an AS path filter that says, only let this AS into my network. That's an example. What else in eBGP? Use a password again. Some ISPs use passwords, others don't. Maximum prefix tracking. Quite a few people use that. If you only ever expected to get 1,000 prefixes from your peer, you probably want to just set something up so that you'll disconnect the session if they suddenly send you the full BGP table. So quite a few people will use maximum prefix tracking. You can get it to do things like shut down the BGP session if it goes over, or just repeatedly send you warning messages. You can get it to restart the BGP session after an hour, just in case it was configuration error, all this kind of stuff. So it's fairly configurable how you can handle it. I mentioned the maximum AS path length. Log the changes of neighbor states. That's pretty useful as well. And keep an eye on the logs also. Make the BGP administrative distance higher than that of any IGP. Now, again, it depends on your defaults. Some defaults for eBGP have the admin distance 20. So if you learn external prefixes by eBGP from your own infrastructure, they're going to override your IGP, which is probably not too useful. Again, I can just say been there, done that. So it's not very pleasant trying to unravel from that one. So if you make your BGP administrative distance higher than your IGP, then you save that accident from happening. Summary of all this, try and use configuration templates, try and standardize configuration, just generally makes things easier. Keep aware of standard tricks, to avoid compromise of the BGP session. Generally just do anything that just makes your life easier. And also, you want to think about scalability. If your network doesn't scale, then, well, it's not going to be successful, or you're going to have to work a lot harder to keep it running. So the general goal of all of this is try and keep it simple, try and keep it scalable, use templates as much as you can, be aware of industry best practices, keep an eye on what they are, don't go on anything static like this tutorial. Dear Philip, I read your tutorial from 1998, and I've been following what it says. Well, don't, because it's 10 years out of date. Okay, so keep an eye on tutorials like this or from anybody else and so forth, what the industry best practices are, sit on the different operational group mailing lists, NANOG lists can be useful for some of this stuff, or if you're other parts of the world, look at those operations lists there, and you generally keep abreast of what's going on. And that is it. So I finished 15 minutes early just so that I can get out of here and go to the community meeting, which starts in 15 minutes time, as I said, along in the Emerald Room. You're all welcome to come if you would like to do that. If you don't want to go, there's the welcome party this evening and the, Bonaventure Brewing Company. Otherwise, we'll see you all tomorrow. Thanks for coming.